In this video, we are going to cover divergence theorem examples, some more examples. So use the divergence theorem to find this surface integral where f is equal to 3x plus zi y square minus sin xz j plus xz y e to power xk, and s is the surface of the box 0 less than equal to x less than equal to 1, comma 0 less than equal to y less than equal to 3, and 0 less than equal to z less than equal to 2. So by divergence theorem, this surface integral f dot n is equal to volume integral del dot f. So first of all, we'll compute the divergence, and computing divergence, del dot f vector is equal to 3 plus 2y plus x. Then volume integral is equal to this. We'll put the value of del dot f in this formula. So we will get this integral, and then first of all we'll integrate with respect to x. So we'll get 7 by 2 plus 2y. Then we'll integrate this integral with respect to y. So we'll get 39 by 2, and finally with respect to z we'll get 39. So this surface integral is equal to 39. This is the final answer. Next example, verify divergence theorem for f is equal to xj plus yj plus zk over the sphere x square plus y square plus z square is equal to a square. Divergence theorem, surface integral f dot n vector is equal to volume integral del dot f vector. So compute the divergence first. So computing divergence, we will get here the value of divergence f is equal to 3. Then we'll find the volume integral. So volume integral, when we put the value of divergence here, so 3 we can write outside of integral because it is constant. So volume of the sphere of a radius a, we'll write the volume here. So that is equal to 4 by 3 pi a cube. That this value we are going to use here. So this will be equal to 3 dot 4 by 3 pi a cube. So this is equal to 4 pi a cube. So then surface integral we are going to find now. So f is equal to xi plus yj plus zk, and n vector is equal to vector r by modulus r vector, which is equal to 1 by a xi plus yj plus zk. So we'll find f dot n vector, which is equal to a. Put all this value here. So a dot surface area. So a dot surface area will use here a dot 4 pi a square, which is equal to 4 pi a cube. So left hand side is equal to right hand side, and this is the required result. Use the divergence theorem to evaluate this surface integral f dot n vector, where f is equal to x square plus y square j, x square I plus y square j plus z square k, and s is the cube in the first octane bounded by x equal to 1, y is equal to 1, and z equal to 1. So by divergence theorem, this surface integral is equal to volume integral. First of all, we have to compute divergence. So divergence of f is equal to this. So set up volume integral, since the region is the cube, 0 less than or equal to x comma y comma z less than or equal to 1, means the limit of x, y and z is from 0 to 1. So putting the value of divergence f here, and then writing all the limits, we'll solve this integral first with respect to x, and we'll get this. Then with respect to y, and then with respect to z. So finally, with respect of, after solving this integral with respect to z, we'll get final answer 3. Next example, find the flux of f x y I plus y z j plus x z k outward through the surface of the cube cut from first obtained by the planes x equal to 1, y equal to 1, z equal to 1. So using divergence theorem, surface integral f dot n vector is equal to volume integral del dot f vector. So first of all, we'll compute the divergence. So divergence is equal to y plus z plus x. Region of the integration, cube is in the first octant, 0 less than equal to x comma y comma z less than equal to 1. So we'll put the value of divergence f here. Again, we'll integrate this with respect to x first, then with respect to y first, then with respect to z. So you'll get the final answer 3 by 2. Thank you. Link of the PPT is given in the description box.